Bismillahirrahmanirrahim. Welcome to Matrix session. This is one of the core part of linear algebra, and today we will look the basic matrix. What is a matrix actually, and it's also the different kind. And in the subsequent session, we will learn about the matrix operation, matrix decomposition, and how it contribute or important for a fine tuning on and so on. So before I giving to the introduce of each matrix, I want to show the I want to share with you that what was the use cases of matrix in specific machine learning. Well, we all know that machine learning or linear algebra both has a vast area, but matrix itself or its operation huge. We will not talk about everything here, as this is our focus is particularly machine learning specific. So I'm just sharing some common metrics that we will see often and use uh, regularly. So okay, so what was the use case? Principal component analysis. Whenever we deal with the data set and to reveal the information that, like a tabular data, it has consist of row and column. So you can uh, we will have to analyze the data to find any relationship with, for example, name what is a feature of the data set and age is feature. So we see that there is no way we can define that the name is strongly related to the age, name can refers to the age. So we can see that so there are many features have in our data set which actually no strongly connected with our the target value. So this type of thing we handle in the terms of principal component analysis. Variance and correlation between the features, which also denote with the matrix, singular value decomposition, rotation and reflection transformation. Well, when for example we have a image data set to more specific medical image data set. So in these cases particularly we have very limited data, as they are very credential. So what we have to do, we have to create synthesis data, or we have to make the data set large. How? We have a image, we rotate it or rotate it 30-degree or 60-degree, then make another image. So actually a image is a sort of value of matrices. We see a image behind the scene, it was a number is matrix. So do not long about this, we just directly go through the basic matrix terminology. Well, so before I deep dive into the classification, well, what is matrix? A matrix refers to a rectangular array that number arranged in columns and row. Well, so numbers and row. And what does it mean? First of all, how we have denote a matrix. We can often see in our school or college, we can denote this two-way. This two-way is the very common. So like this, we denote a matrix. Then now rows and column. Okay, like this is a matrix. Yes, I have the sign. So I assume that this is my matrix, or also I can write this way. So I'm sure that, yeah, this is a matrix. There is no doubt. Now, the terms come here, rows and column, combination of rows and column. Well, uh, you all know that. Just for simple recap, row and the way we consider the column. Okay, so each of number is called the element of matrix. So the position denote, how we will denote the position. Okay, uh, let's assume this variable a11, a12. Oh, mistake. Okay, so if someone said 2, exactly it 2 can be where? So we don't know actually. In matrix, the 2 means what actually? If someone told me that A11, then I can sure that the matrix position is here in the first row, first column. The first one is represent the row and this one is the column. So if someone said that like we want to construct a matrix here, okay, 11 0 9. So we don't know the value of B22. So if someone told me like B22 is 9, so what I have to do? Okay, 91, we can assign this value. First of all, we look at this, the position of the element. Second row, second column. Okay, this is the first row, second row, first column, and this is the second column. So we can put here the value 91. Okay. A matrix can be a null matrix. We know that null means 0. So row matrix, if we have just only a row, then it called a row matrix. And the row matrix dimension or the order we can denote like this. I don't know actually how many column will be. So we can see here only 3. So we can write it 1 into 3 or 1 into n, which means that the row vector can be goes to infinity. Obviously it has limit, just for simple understanding. So similarly you can guess what about the column matrix. A column matrix which has only one column. So n number of rows, we know this is the row, and only one column here. So we can write it down like this. This is the very important. We have to know that exactly the order of a matrix. Okay, so far we have covered how matrix denoted, what is the important in machine learning, and how we have to uh, like write a row matrix and a column matrix. Now moving on to the square matrix. Well, we know whenever the name square is come in our mind, okay, there is a well shape. So this is a square. We all know because it's all sides are equal. So what was about the square matrix? Well, a matrix when is both number and row is equal. We can denote m is row, n is column. It is called a square matrix. How? Look like this. Okay. Can I say this is a square matrix? No, because the number of row is 2 and the number of column is 3. So according to our condition, the condition satisfied m equivalent, so the condition is not satisfied. That is why this is not n square matrix. But yeah, like if someone say like this a matrix is square or not, well, this is a square matrix because both column and rows are same. So how do we write this, the order of a matrix? This is 3 into 3. Okay, another kind of matrix is called symmetric matrix. A symmetric matrix is a type of square matrix where top right triangle is similar to the bottom left triangle. Well, so before goes to here, like, okay, we have to draw another matrix. 1, 2, 3, 4, 5, 6. So we can divide it like this diagonally. Well, we will also before cover it, what is diagonal. If someone say what is the diagonal matrix, this is called the diagonal matrix, we know that. So it's look like 1, 5, 9. This is our diagonal matrix according to this matrix. So this one called top triangular, and the below one is called bottom triangular. So we can say that a square matrix is combination of two triangle, bottom triangle and left bottom left triangle, and it's the top right triangle. To more specifically, if we say one to this. Okay, so if we want to draw a matrix like the symmetric, so how it would be? Well, there is the condition is like this. M, we know that the square matrix is M equal to N, both row and column equal. But here, what does the M? M is fully a matrix, which is a square matrix, 3 into 3. And on the other hand, this is the transpose of matrix. We'll see in the other session about the matrix operation. Today we will see here, like, uh, simply to say transpose means row convert into column and column convert into row. Well, okay, so if this is equal, then we can say the matrix is symmetric, otherwise we cannot say. So like, so this is a square matrix, 3 rows 3 column. Okay, if I this is M, if I transpose this, look like this. According to the transpose, row converted into the column. Sorry, uh, column is row. Okay, then 2, 1, 3, then 3, 2, 1. Okay, I made a mistake, but the written everything is okay. Each row convert into one column. Okay, so this row convert into a column, this row here and this row here. Okay, so if you closer look at this above the two matrix, so can you see these are similar? I see this is okay, I made a mistake here. 3 2 1, but according to our transpose matrix it is not similar, like the diagonal is same 2 3 3 2. This is not same, so we cannot say this, like if m is not m of t, so we cannot say this is a symmetric matrix. Okay, now moving on, specifically triangular matrix. Okay, so if someone say, or if you see where that upper triangular, we already know that a matrix, specifically square matrix, is combination of both upper and lower. So what does the upper means? Well, upper matrix means that the lower matrix, I mean the bottom matrix, should be 0. Okay, if you draw a line from the diagonally, we can see that the bottom left are 0. This is called upper triangular. On the other hand, what does the lower triangular matrix? Well, 1 0 0, 2 1 0, 3 1 1. So if you look at this, if we draw a line through a diagonal, then we can see that upper one is 0. This is our triangular matrix. Already I told about the diagonal matrix. So what is the diagonal matrix? Like this one, where values outside of the main diagonals have a 0 value. Okay. So diagonal matrix often wrote as a D. So we can sometimes someone somewhere you look like this. So what does it means? Well, it means that only the diagonals value have something like this. So without diagonal, others value are 0. Now we have to correct our definition. What was actually diagonal matrix? A matrix where outside of the main diagonal have a 0 value. What does it means? This is our main diagonal. Well, about this rest of the element are 0. Then we can say a diagonal matrix, and it oftenly denoted as like D11, D22, D33. What does the D11 refers? 1, D22, D33, this one. Okay, so our next one is identity matrix. Identity. Well, an identity matrix is also a square matrix that doesn't change the vector when it multiplied. What identity matrix where each diagonal value is same. So can we see, is there any relationship between the diagonal and identity? Yes. In the diagonal matrix, the diagonal value can be anything different, but here in the identity matrix, it must be equal, same. If we draw 21 here, 21, 21. So if we take a common 21 here, then the matrix look like. So definitely this is an identity matrix, and identity matrix is often denoted as I. So that's all about the kind of matrix. So we can, as our goal and purpose, this use in machine learning. So we have to do some code how we matrix perform with the Python. With help of NumPy, we can perform the matrix. So here you can see that, okay, if I make a large one, this, so the square matrix, see, this is the size. We firstly we draw and array, make a array, 2D array, and just simply print this, so we can see the same output here. Okay, I have to try this one. Yes, it can't also the print shape. So if the shape is same, then we can see that this is a square matrix, otherwise not. So let's see what it returned. Well, there is an extravagant one. Okay, probably it matched the value, but we don't know. So this is our square matrix, and I told you that the symmetric matrix. So consider we have a matrix like this, and if we transpose the matrix, then it is called our symmetric matrix. Okay, we want to print here the G symmetric matrix, which means that the transport of symmetric matrix. Okay, you can match one, one, two, two, three. You can see similar. So we check here if the symmetric matrix, symmetrics and transpose matrix both are equal, then we can say that is a symmetric matrix. Okay, for our understanding, we just change a value like this one. Sorry. So this is say false. If you look at closer, that every value are same except this one, b, 2 3 2 3 and 2 3 actually is different, otherwise rest of the value are same. It returned false. This is not a symmetric matrix. Okay, now come to the triangular matrix. Okay, we can like, this is a triangular matrix. We can so also this is, and there is a typo mistake, no typo mistake. We know that the lower triangular matrix, which the above diagonal values are 0. So this is the things here. Now look at the diagonal matrix. We can denote a diagonal is like if someone say this is a diagonal, where we find this diagonal. Okay, if we run this, we can see other values are 0. So if I change here this with a value, and if I run this, we can see that the others value who accept the diagonals value are 0. This is the diagonal matrix. uh, Another example, if we can look at this is the we created a random matrix. So if I call the diagonal of m, this is our m matrix, it just return 11, 23, 34. Okay, I set a bigger value here, so it returns this diagonals value. So right now consider I have these three values. So if someone say me this is a vector to create a diagonal matrix, how do I do this? Just if I run this, then it will change like this. Okay, and uh, today's final one is the identity matrix. So we just call the identity 3, and it goes, we find a 3 matrix here. If I do, then identity matrix this one, and obviously identity matrix is a square matrix. We also create other way numpy dot I. So if we pass 2 here, then I can see this one.